Welcome once again to the studies of the mathematics of numbers. Today we will start studying the physics of numbers, as I promised last time. The reason is that the numbers are flexible. Numbers have a structure that allow us to study them. Especially today, we will begin with the studies of the acceleration, deceleration, and the expansion of a number. We will study this because numbers vibrate. And when an object vibrates, it has a speed. Speed involves distance and time. We learned last time that numbers move between the levels of variability. And in the process, they can increase the value or decrease the value. Increase means acceleration and decrease means deceleration. So to begin with, let's study the acceleration. We can understand the acceleration of a number. We understand first how the universal acceleration works. You know all that gravity is the universal acceleration. How does it work? We have to refer to Galileo's experiment, because Galileo was the first one who studied how objects behave during the free fall. Therefore, he was able to derive to some conclusion, and the best he got for that is that the distance that an object travels during the free fall is directly proportional to the square of time. And how he got it? Here is a diagram that illustrates Galileo's experiment. First, he set a unit of time. Then he let an object fall. Then he measured the distance that a body travels during the first unit of time. And he set that as the unit of distance. Then he wanted to know how far an object can travel for 2 units of time. And he found out that the object will travel 4 times. So the distance is 4. For 3 units of time, the object will travel 9 times. For 4 units of time, 16 times, etc. So he concluded that distance equal time square. What is important to us in this experiment? We are talking about acceleration. And what is acceleration? Acceleration means a constant increase of speed. Let's find out how it works here. You see very well that during the first unit of time, the object traveled only once, so the speed is 1. But during the second unit of time, the object traveled 3 times. That's what makes 4 here as result. 1 plus 3. Then during the third unit of time, the object traveled 5 times. Next 7, next 9, next 11. Continue. So what do we learn from here? We see very well 1, 3 means 1 plus 2. 3. 3 plus 2, 5. So the speed is increasing 2 times the unit of distance for every next unit of time. And that is the constant of our acceleration here. We will not go into formulas, but it's just to give you an idea that for gravity, the constant is always plus 2. What about numbers? So for numbers, when numbers accelerate, they also have a pattern to follow. We always accelerate numbers, but we don't realize it. Just when you start counting objects or time, you say 1, 2, 3, 4, 5, 6. That's already acceleration of number. Because every time you are increasing by 1. So you are adding 1, and 1 is our constant. So to accelerate a number is to count it upward as many times as the number itself by just adding 1. I will give you an example. The example is with number 4. Let's place this number 4 here and accelerate it. We'll add 1, 2, 3, 4. That's maximum. So 4 times only we have to go. That's why you see here 4, 5, 6, 7, 8. And you sum up all these numbers, they gave us the acceleration of a number. Observe very well that the beginning is the number itself, and the end is the double of that number. So the number you will get always at the end will be 2 times the master number. Now let's see how the deceleration works. The deceleration works in opposite way. We have to count the number downward. So we will go from the number and reducing all the times by 1, 1, 1. And an example is with number 4. If we have to decelerate number 4, we will go 4 steps down to 0. So you'll go 3, 1 step, 2, 2 steps, 1, 3 steps, and 0, 4 steps. So this is how we decelerate numbers. And if you want to know how much, then sum up all these numbers. You have 10. So observe well that we went from 4 down to 0. That's the deceleration of a number. So to decelerate a number, really, you have to go from that number all the way down to 0, because the last number you get there, or the last value you get there, is n minus n. So that's a 0. Now, I would like to give you an example of deceleration. so that you can understand very well how deceleration works. And I would like to take you to NASA, because at NASA they launch spaceships to the space and rockets. What happens there? The operator will set the time at 10. So you have a slice of time which is called 10. However, even though the operator will say 10, the spaceship cannot go. It cannot take off. Why? Because this 10 is very thick. 10, inside 10 are other values. So what he has to do, he has to slice the 10 into pieces of 1. Therefore, he will start counting 10. As soon as he says 10, the slice of 10 is gone. Even though we don't touch numbers, but if we are there watching and listening to the operator, then we will see the slice of 10 flying away. And what will remain is only a slice of 9. When he says 9, the slice of 9 is gone. What remains is a slice of 8. And why we do this? Because you cannot empty 10 by just removing the 10 and then down to 0. No. If you want to reduce 10 down to 0, you have to remove every piece one by one. So you remove 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then 0. Go. So that's the deceleration of a number. Numbers are not a block. Numbers are a compilation of units of 1. So now we have learned already about the deceleration and the acceleration. And these two have a very special relationship. Therefore, we need to formulate them together. If we have number 4, for example, we will decelerate it, then accelerate it on the other side. For the deceleration, we knew that we got already 10. For us to know how we got this 10, we have to refer to 2 elements we have here. So we have only 2 elements of data. These are the number itself and the constant, which is n plus 1, meaning 4 plus 1. Therefore, we will have 10 equal 4 times 4 plus 1 divided by 2. And for any number, we get n times n plus 1 divided by 2. That's the formula. As simple as this. Then we saw that in order to get the acceleration, we have to sum up all these numbers. And they gave us 30. You see the relationship between 10 and 30. 10 is 3 times less than 30. And 30 is 3 times more than 10. So we can just get the formula of the acceleration based on the formula of the deceleration. So we'll have this. We have 4 times 4 plus 1 times 3 divided by 2. And as for any number, we will have n times n plus 1 divided by 2, the whole multiplied by 3. So that's the acceleration of a number. So now we have studied, and we said already that these two numbers, if you know one, you will know the other. You will know, if you know the acceleration, you will know also about the deceleration, and vice versa. From here, we can now study the expansion of a number. To expand a number is to count it in both directions, downward and upward, as many times as the number itself. So we will do this. We have our number here. We go all the way. The last number will be n plus n, to n, and on the other side it will be n minus n, 0. So we have to sum up all the numbers here, then they will give us the expansion of a number. An example is here for number 4. So what we do, if we have number 4, we accelerate and decelerate it. That gives us the expansion. Then we sum up all these numbers. They give us 36. What is 36? 36 is 4 times 9. 9 is 8 plus 1. So 2 times 4 plus 1. Therefore, the formula for the expansion of a number is n multiplied by 2n plus 1. That's very simple to do. Now, we have already studied all of these. At least we have started today with the acceleration, the deceleration, and the expansion of a number. What for? We have to study this because we are building an identification card for numbers. All the numbers, they have an ID. And on that ID, you will find the acceleration, the deceleration, the expansion, and other values that we are going to study in the next lectures. I would like to show you for number 4, for example, what we have studied today. That this is the identification card of number 4. It is so because we have 4 here as the master number, and this card depends on the number of levels of variability of the master number. 4 has 5 levels of variability. That's why you see here, when you start here, 1, 2, 3, 4, 5. If you have a bigger number, of course, you will have more levels of variability, and the card will be bigger also. And what we observe, that the master number appears here on top. The deceleration will appear in this corner. The expansion will appear here at the bottom corner. Then the acceleration will always appear at the right corner. These make really the pillars of the card for number 4 and for all the numbers, meaning this deceleration, the master number, the acceleration and the expansion are the pillars. And other values will come here. Those we will be discovering next can be written on these cells, and all they make a meaning, and all are interconnected because they describe only one object, which is 4. And why we need this? Because numbers represent all things. I mean, there is nothing that we can't identify with numbers. We use numbers to quantify things, to quantify time. So even time we do with numbers. Therefore, numbers are the key. If we want to know the information about an object, we have to attribute to that object a certain value, which is a number, will be called a master number. Why? Because this theory is a theory of information. We will study only 100% information here. Therefore, there is no formula of what you have studied already before. But the good thing that when you have all this data here, it can help you to quantify the information of any other object. I would like to give you the example of, for those who study the black holes. If the black hole is 400 million times the mass of the sun, how much is it? You have to find a number to represent the mass of the sun. Then when you process that number, then you will get all the information about the sun. Then you can also tell how much information is in your black hole based on the sun. So that's the advantage. That's why we are doing this one. So these are pure physics we are doing here. Don't take these mathematics lightly. They are real. So please listen to me. Continue following what I'm going to give next. Next time we will be talking about the projection of a number. And that will give us all the details that are missing on this card. Because we will study it in 1 dimension, 2 dimensions, and 3 dimensions. And we will see all the results coming out here. And that makes the ID of a number. All the numbers have ID. And when you put all the IDs together, they make what we call the map of the information of the universe. So we are not doing small things here. Please follow me again next time. Thank you very much.